Any time that you are being asked whether or not two triangles are similar, the first question you want to ask yourself, do I have all 6 side lengths? If you are given all 6 side lengths, then you want to try to see whether or not there's a ratio there that you can use. The way you find out is you take the two triangles and write the small, medium, large size here, the actual length of the side, and then triangle 2, small, medium, large, and then you actually make fractions out of them and see if they're equal. If they are equal, then you have side, side, side similarity. And the only question is, how are you going to write the proof? Well, first thing you want to do is list all the side measurements as given. You got to list them or you won't get credit. The next thing you want to do is show the proportions using the side names. So in other words, if the small side is AB on one of them and ZY on the other, that's how you want to write it. And show that it is equal BC over YX. So you're writing out the side names. And then you include the scale. If they all reduce to the same fraction, you write what that fraction is over here. So this is equal to this is equal to this is equal to this. Okay? Now, you have to create a similarity statement, which means triangle something, something, something is similar to triangle something, something, something. And the way this goes is when you do if I do ABC, right, AB is going to be equal to, AB over something over here is going to be equal to BC over something here, and that's equal to AC over something here. Well, guess what? The letters have to be in the same relative place. So you notice Z is here and Z is over here where A is. The one that happens at the beginning and at the end is Z, and the one that happens at the beginning and the end is A, right? Because you're going all the way around the circle. That means Z, the angle Z, is going to be congruent to the angle A. Okay. And since we know that ZY goes here, we know that Y and B have to be related to each other. They have to correspond. We know that angle Y is congruent to angle B. And over here, the only one left is XZ. Actually, I should put this here too. YX. So Z corresponds to A, X corresponds to C. Angle X is congruent to angle C. This right here is the definition of triangle similarity. The sides, the corresponding sides have the same proportions, and the corresponding angles are congruent. This similarity statement has to show that, so that A and Z have to be in the same place if they're the congruent angles. B and Y have to be in the same place if they're the congruent angles. C and X have to be in the same place if they're the congruent angles. Okay? So, the one other thing, couple of things to point out here. Things that will just blow you out of the water that you can't do, okay? I have no idea what that means. Right? You can't have a point over a point equals a point over a point. I see that a lot. Doesn't mean anything. This means similar, which means the same shape, but not necessarily the same size. Triangles can be similar. Angles cannot be similar. Because if the angles are the same shape, they are the same size. Another thing you can't, makes no sense. AB is similar to BC. Well, same shape, but not necessarily the same size. Well, if this is a line segment and this is a line segment, what does it mean to be the same shape but not necessarily the same size? They're both just sort of flat one-dimensional things. They're either the same length or they aren't. So this doesn't mean anything. Anytime I see these, I just stop looking at the proof because it means you really don't know what the symbols mean. The other thing is, this does not say that AB is congruent to ZY. Okay? That's not what this is. Congruent means they're the same size. These are not the same size, but they have a ratio that is the same as this ratio and the same as this ratio. So sometimes I see like this. You're trying to tell me that you've noticed that these two are corresponding. That's not what this means. This is the way you write it. This is what it means. Okay. And then you write this, and then over here you write side, 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 similarity. Now, that was the first question. We come over here, we look at this, we go, do I have all 6 side lengths? No. All right. The next question you ask is, can I find 2 pairs? Notice 2 pairs. That means 4 angles altogether. Can I find 2 pairs of corresponding angles that are congruent? So you're looking at this, and none of these angles are shown to be congruent. But here's something you can tell right away. These 2 are vertical angles. So angle ACB is congruent to angle DCE. And the reason for that is vertical angles are always congruent. Okay? So that's one pair of angles. Do we see any others? Well, the thing is, these 2 lines are marked as parallel, which means that when a transversal crosses them, we're going to be in the situation where we have a bunch of angles that are congruent or supplementary. So we have to say AB is parallel to DE in order to set it up, and say that's given. Okay? That's given. Once you've set it up, now you can use that fact to say angle ABC is congruent to angle CDE, right, here and here. And the reason for that? These are alternate interior angles created by a transversal that are crossing lines we already know are parallel. That is the alternate interior angle theorem. Okay? So now the answer to this question, can I find 2 pairs of corresponding angles that are congruent? In this case, the answer is yes. Here's one. Here's the other. So I got these 3 things, but we're not done. If you stop here, you haven't done the proof. What you want to prove is that there is a triangle ABC that is similar to another triangle, and we got to make sure we put the angles that are congruent in the same place. The angle that is at vertex B is congruent to the angle that is at vertex D, so that's got to go in the middle. The two angles that are vertical angles both share the vertex C, so that has to go at the end. The angle that has the vertex A and E are also congruent. So that's the C and the... Did I do that? Yeah. That's where I want to be. C and C are in the same place. A and E are in the same place. B and D are in the same place. And that's when you put angle-angle similarity. Okay?
Yeah.
Now, let's pretend for a moment that instead of this, that we're looking at this, and we don't have this. We don't have that the lines are parallel. We're looking at this, and we're saying, well, do we have two congruent pairs of angles? And the answer is no. We've got this one here, but we don't know that this is congruent to this, and we don't know that this is congruent to this. So here is what you ask the third time. If you only have one pair of congruent corresponding angles, do you have all four side lengths that make those angles? Well, if we're looking here, and let me get a copy of this that I haven't written all over. If we're looking here, if this wasn't here, and all we had was this, the answer would be no. We've got this side and this side, but we don't have this side and this side. At which point, if the answer to all three of those questions is no, you're done. You do not have triangles that you can prove are similar. Now, we do have this, so if you had noticed straight away, forget about this, I didn't notice this at all, but what I did notice is that the lines are parallel, and I have this angle and this angle that have to be congruent because of the alternate interior angles theorem. Do I have all four sides? I sure do. I got this one, I got this one, I got this one, and I got this one. So now what do? Well, in the two different angles, I take the small side and the large side, right, 6 and 10, and compare them to the small side and the large side, 21, 35, and ask, are these equal? You can simplify, right? I can reduce this by 3, divide top and bottom by 3, I get 2 over 7. I can reduce top and bottom here by 5, I get 2 over 7. So yeah, they're equal. That means you have two side lengths with a ratio that is equal to the ratio formed by the other two side lengths, and the angle in between them is congruent. You got side, side, side. In this case, if we wanted to do that proof, what we would have to do is first say AB is parallel to DE so that we can set up the alternate interior angle thing. That's given. Then say angle ABC is congruent to angle CDE because of the alternate interior angles theorem. Then say we have, you got to list the side lengths. AB is equal, AB without the little hat, AB is equal to 6. BC is equal to 10. DE is equal to 21. And CD is equal to 35. That's given. Yep.
Why don't you add the line over
Here's the thing. When you put the line over it, you're talking about the segment. When you don't have the little hat on it, you're talking about the side length. So this actually is a number, and this is a drawing. Now I can say AB over DE is equal to BC over CD, and that's equal to, what did we say? We said it was 2 over 7. Yeah, 2 over 7. Okay. Those are just proportions. That's all you write. And now you have enough so that you can say triangle ABC is similar to triangle EDC. Okay? And why? Because of side angle side similarity. Couple of quick things. This says congruent. This says similar. If you're talking about similar, you want to use this. Thing 2. If you're looking at a drawing like this one, and you want to talk about these two angles here, you cannot say angle C is congruent to angle C because I will have no idea what you're talking about. If two angles share the same vertex, you need 3 letters to identify them. That angle and that angle are the ones that are congruent. You do have to list everything that's given in order to be able to use it. Yeah, what's your question?
Does it matter the order that we put in as long as they correspond to each other?
Nope. So in other words, if you wanted to say this is triangle CBA, this would be triangle CDE. Okay? Yes, sir.
How come we wrote that line AB is parallel to line DE? And you wrote that's the given. Like, how come that's the given one? Like,
Right here, these two little symbols here,
yeah.
this means that the 2 lines are parallel, and I need that in order to be able to say that these two angles are congruent.
But like, could something else be given? Like, why didn't you do like line AC something to line CE as the given?
Because it's not. What's given? Given means like what's in the drawing. What did the person who gave me the problem tell me was already true?
But remember how like before they had problems where it's like it's already like written down what's given, like.
Right. If sometimes it's given to you in the drawing, sometimes it's given to you as a list. You can do it 2 ways. If you have the list that's given, that's fine. But if you have the drawing, you got to interpret the drawing. Question? Just. You mean over here? Here? Because I did the small to the small and the large to the large.
But there's no like third number here.
Yeah, well, there's no medium. But I got small and large. Right? Small to small, large to large. Okay? I don't have small, medium, large. With side, 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 I've got small, medium, large. The only way that you can say that 2 triangles are similar to each other is either you have angle, angle, you have side, 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 or you have side, angle, side. Nothing else can go here if this is what you want to prove. And these things can only be used to prove this. So, for example, the idea of saying, well, angle A is congruent to angle B because of angle, angle. That makes no sense at all. So don't do that. Here's the deal. If you have all 6 side lengths, you can do this. If you have 2 angles, 2 pairs of corresponding angles, you can do this. If you don't have either of those, your last chance is to have 1 pair of corresponding congruent angles and all 4 side lengths that make those 2 angles up.
Keeping a